Greetings, Earthlings. All right, let's review where we are with this Keithley 171. I bought this off of eBay. It was sold to me as tested and working, removed from a working environment. When I got it, it clearly didn't work, and so there was some negotiation with the seller who gave me a partial refund because I wanted to keep it and try to fix it. So, what have I found so far? Well, I went through the power supply. I found one bad capacitor, electrolytic capacitor in the power supply, but I went ahead and replaced all of them. Checked the carbon composition resistors, found a number of resistors that had drifted out of spec. There was a light bulb on the front panel here that was burned out. There was on the AC board a bad op amp, which was pulling the power supply down. There was the wrong capacitor in the analog to digital converter board. And finally, and most recently, there was a bad switching MOSFET. On which board was that? Oh, that was the analog board. Okay. So far, pretty much every board has problems. This leads me to believe that this was not removed from a working environment, but was removed from a dumpster. And it's acting a lot more like this was a parts unit, like whoever owned this had multiple instances of the meter, and as things would fail on another one, they'd swap boards out to keep that one operating. Like I said, that's pure speculation on my part. But given that that board had a problem, that board had a problem, and that board had a problem, power supply had a problem, well, the power supply would not have been swapped out. It leads me to believe that, things, you don't get multiple problems happening simultaneously. So this could not have been used with all of these problems in it, and for some time. And did they continue to leave it powered on so that more things could fail? I don't understand. Unless something I have done in the process of trying to fix it has caused these cascading failures, but I doubt that as well. So at this point, I did find one other thing, which I'll show. But at this point, we now have it semi-functional. It works up to about 8,000 counts. Works reasonably well. Putting 4 volts in, putting 5 volts in, 6 volts, 7 volts, 8 volts. Okay, and then when I go to 9 volts, the count maxes out. That leads me to believe there's a problem in the counter circuit, which is underneath this board. So it's also the display board. So that would be every board having a problem if it turns out to be there. The other thing, as I said, I did. I noticed in the first video when I tore it down, when I opened it up, I found a loose wire hanging out there like a jumper, and I wasn't sure what that was. And I now know when we go to no range here. See, okay, so I'm on the 1 millivolt range, and it can't do 1 millivolt, but it's actually reading whatever the output is. That jumper actually is shown in the schematics. It's right here. Okay, and it goes J401 to J404. And then there's J404 connects to P404. Okay, well, where's P404? Well, I figured that out. That's on the motherboard. This is the way the motherboard is laid out in here. So by sort of buzzing it out, that's P708, that's P707. You can see that P404 is connected to P708 pin K. P708, that's A. And we come across here, that's K. So that says that pin right there, which is right there on the motherboard, is where that's supposed to connect. Let me see if I can tilt this up and show you. All right, can you see that in there? So this is that wire. This here is P708, and that right there would be P404. So that goes on there, which, you know, if you had to guess that it connected to something, that would be what you guessed. Okay, so that's now on there, and if we put it back, what we'll see is on that 1 microvolt range, which is not capable of doing, it's now saying no range, but it's not showing a count, it's just showing the overflow indicator. Okay, that's kind of cool. Well, that also tells us the overflow indicator is working, and so that the count, which stops at 8100 and something, is not at 18, something. Okay, did that fix the problem though? Well, let's go back to the 10 volt scale. There's 8 volts. There's 9 volts. Of course it didn't. Okay. Okay, so now we got to figure out what's going on with the counter. I look at this and I say, this is suspiciously close to 2 to the 13th. But I don't think that's significant because this uses decade counters, not binary counters. It's also suspiciously close to the ratio of 50 hertz to 60 hertz. But again, I don't think that's significant because there's no setting in this to operate at 50 or 60 hertz. It just it'll operate at either, and so yeah, I don't think there's anything with that. So what is it? Well, I don't know. So the first thing we can do though is check. There's a crystal oscillator in here. Crystal oscillator. And so QA401 pin 13 has the output of that. That's supposed to be 100 kilohertz. Okay, this is QA401 right here. You can see that. This can actually measure frequency. Again, one of the reasons that I like having this meter for doing these videos is it has all these different capabilities, which a lot of meters don't have. So it can measure frequency, to some level of accuracy. For our purposes here, we're looking for something around 100. It's a crystal, so it should be spot on, but if this isn't perfectly accurate, that's okay. It can measure capacitance, it can measure inductance. It's just a good all-around meter. So this is ground here, and pin 13, I think I said, is right there. And that's showing 99.9 kilohertz, 100 kilohertz, yeah. So at least that part is working okay. So why does it stop at a count of 8,000? That is the question. Could be something wrong with the counters. There's two things that would stop that count and cause it to latch under normal conditions. One is that the time period expires, and the time period, the counting time period, is supposed to be 200 milliseconds. So it would count to 20,000, or 19999 and stop there. The second one is that if there's a zero crossing, because this is a dual slope analog to digital converter. It's it uses those counters on both halves when it's charging and discharging. But on the discharge cycle, it's checking for a zero crossing, so it will charge it for the full 200,000 cycles, and then it will discharge either for 200,000 cycles or until it sees a zero crossing. And so either it's not counting all the way, like one of the counters is bad. It would be the high order counter. The what do you call that? Thousandths digit? I don't know. Or the zero crossing detector is bad. Well, we know the zero crossing detector basically works because it works fine at lower voltages. Why would it care if it starts at a higher voltage? It's just looking for zero. So we'll have to dig into this and figure out what's going on with that. All right, so finally I've broken out the oscilloscope for this one. Probably could have used it sooner, but I wanted to, I intentionally went with less than my full capabilities there, I guess, Okay, what I've done here is on the, they call it the tube board. It's the counter, the output board, what have you. These are the decade counters here, okay? And they're being clocked at a 100 kilohertz rate. And so the highest one clocks this shift register here. So I've set a test whether the oscilloscope is connected to this point. If these are working properly, then we should see 10 hertz, and because of the way these 7490s are wired, it will be a 20% duty cycle. And that seems to be what we see. It says 9.95 hertz. I don't know how much we can trust the frequency counter in this scope, but that's still pretty close to 10 hertz. And is that 20% duty cycle? It sure looks to be about that. So it appears that the counters are working okay. The counters can count. Oh, well, wait, I have nothing in. Let me put the 10 volts in. Well, it shouldn't make a difference. No, it doesn't make a difference in terms of what the counter does. So counter appears to be counting just fine. And the problem is somewhere else, which in some ways is a good thing because those counter chips are soldered in, they're not socketed. And I don't have any replacements on hand. So the next thing to look at, I guess, would be the output signals from the shift register here. They come to the back, like the back panel here. 0, 1, 2, and 3, 4. And see kind of what those look like. Okay, and this should be the, let's see, 13. This is the 2 signal. And it looks pretty clean. Okay. So that's pin 13 on that connector. I go to pin 14, and that's 0, 1. I have to figure out. Okay. This is what 0, 1 looks like. Now I'm going to have to figure out exactly what these things mean. That is, they're the different phases of the converter. 2, I think, is 0. So 0, 1, so there's 0, 1, 2, 3, and 4. So 0, 1 should be the counting cycle. And that seems to be a complete, oh, well, wait, let me go to 10 volts. It doesn't change. Okay, so that should be the counting cycle, and then 3, 4 is the charging. So there's here. Wait, look. I've got a picture somewhere here. Integrate is 3, 4. Count is 0, 1, and 0 is 2. Yeah, so that's what I was saying. So so 2 looked fine. We're on. Did I say I'm on 0, 1 right now? Yeah, this is 0, 1, which should be count. And that looks to be doing the full 200 milliseconds of counting. I can check that. What is it, you know? Let's see. 1, 2, 3 out of 5. Oh, well, 2 out of 5. Yeah, 200 milliseconds. So somewhere it should say, yeah, that each thing is 100 milliseconds. I guess that's up there. So 200 milliseconds, and then 300 milliseconds for the other cycles. Okay, so that looks okay. And that was the one that was suspect. And then if we go to 16, pin 16, this is the integrate signal, and again, 200 milliseconds. Okay, so 200 milliseconds, and let me go back to 13. Okay, and that's 100 milliseconds. Yeah, so those look fine. All right, after a little poking around, it looks like the problem is in the integrator. That's stopped right now, but what I've got is 8 volts in, okay, and measuring the integrator at the capacitor. Where's my red pointer? I can't find it. I'm measuring here at the output, and what I'm seeing, well, watch this. Let me turn it back on. Let me start it back up. Okay, that's at 8 volts. Yeah, on the 10 volt scale. I go to 9 volts. See what happened? 10 volts. Okay. 10 volts. I'm now on the 100 volt scale on the 343, Fluke 343, and 20 volts. It's clipping. It has reached the limit, because that's, let's see, 5 volts per division, you see. 5, 10, that's about 12 volts. Well, 13 right there, it says 13. Which is the limit because these op amps can't go to 0. And they're fed from plus and minus 15. Okay? So it should be, based on the values here, 392K and 0.1 microfarad, we should be seeing at 10 volts at 10 volts in like 5 volts, and at 20 volts in it should be like 10 volts, which is within the range. So that seems to be the problem, not the counter at all. So now I have to figure out what's going on. I did replace that capacitor because it had a 0.22 in there. No reason that I could see that it had a 0.22. So my suspicion now is that this resistor is bad. It's the most obvious thing, but we'll see. All right, I found my red pointer. So, I'm going to measure it in circuit, which may or may not be a valid thing to do, but it'll give us some indication. If I measure 390, it's supposed to be 392K. Oh, here, over here. Okay. It's supposed to be 392K, right? You can't see that. Oh. It's supposed to be 390. It's supposed to be 392K. If it measures 392K, then we know we're fine. If it measures lower, which is what it seems like is the problem, then I'll have to pull a leg and see. If it measures higher, then it's all screwy. But it's that resistor right there. I figured it out. So look here. This is a precision resistor here. 117K. Let me turn it around. Reverse the leads, because sometimes they'll look different. 117K. Okay. It looks like that may be the issue, which is thoroughly bizarre. All right, and in the most bizarre twist yet, there's the resistor, and now that it's lifted, I can see a marking of 1183. 118K. And what does it measure? Oops, I said, what does it measure with the leg lifted? 117K. It has a date code on it of 1972. I don't know what that means. It sure doesn't match the schematic. It sure looks like it's the cause of the problem. So I'm going to replace it with what the schematic calls for. Certainly that's less than, that's why the 2.2 microfarad was in there. I don't know what's going on with this thing. I don't know who's been in here and what they had in mind. But it's bizarre.